career, including Green Roofs for Healthy Cities and the Canadian Healthcare Engineering Society. Welcome, Bill. From the design consultant, we have Sal Alajek of WSP Canada. He's project director and national technical lead. Sal specializes in building sciences and existing building restoration. He is a professional licensed engineer and registered roof observer, RRO, with the International Institute of Building Enclosure Consultants, or IBEC, as we might know. His work includes new build design and existing building restoration, ranging from exterior walls, glazing, balconies, roofing, including vegetated and green roofs, podiums, parking garages, and on-grade asphalt parking lots. Welcome, Sal. From the manufacturer side, Denis Gingras of Hydrotech Sika. He's the regional sales manager of the Eastern region with Hydrotech. Denis has been with Hydrotech since 1985, promoting MM6125 in Eastern Canada as a technical sales representative. Hydrotech and Denis introduced green roof vegetative roof assembly in 1998, and since then has been involved in multiple vegetated roof projects in Canada and the New England states. He was also involved with one of the first vegetated roof systems in Canada in Montreal called Place Bonaventure, which actually had a vegetated roof started in 1966.
That's true.
There we go. Denis is also involved in standard waterproofing applications, protected membrane, roof assembly, plaza deck assembly, and parking deck. Welcome, Denis. So Bill, you're up and enjoy.
First. We're good. So the learning objectives for today, we're going to learn about some green roof system types. We're going to look at considerations critical from a design and a material perspective. Keeping the roof system watertight, that's really interesting because the waterproofing membrane is key to this whole system of green roof, and that's what's designed to keep a roof waterproof. But we're going to look at some of the design concepts to make sure that there are no mistakes made in protecting the actual roof membrane. We're going to look at good practices and challenges for green roofs. Then at the end, we're going to talk about industry trends. And then after me, followed by Denis, who's going to do a presentation and talk about some of the other challenges that we see in green roof installation and management. What we're not going to talk about today is blackline. I know you guys love your blackline. I'm an old-time blackline guy as well, but there won't be much talk about blackline today. Sorry about that. We're going to look at the outcome first. You know, I'm pretty passionate about what I do at the later stages of my career, and I just want to show you a few pictures of the outcomes. These are roofing systems installed primarily in the Greater Toronto area, and they look great compared to the gravel and the black and the white roofs. These just look great all across the city. You're going to see a lot of photos here of the CN Tower, okay? Multiple photos, because at our company at Ginkgo, we We love to get a picture of the CN Tower in the background from anywhere on a roof in the city. So you can see a lot of CN Tower pictures here. So these are just some of the green roofs. I just think they look great. This is views of the lake from different angles. This is Sherway Gardens right here. This roof on the right is 50 stories up. Another one at 36 stories up, 20 stories up, and almost at just 2 stories, level 2 for this roof here. They look great, so I love the outcome. They even look great in the winter. You can see in the picture on the left of a green roof install of what it looks like in the winter. So let's talk about green roof systems. And one of the things I want to make note here is that I'm going to go through these slides fairly quickly. When I go through these slides, most of these slides are a 1-hour presentation just on their own, right? So we're going to cover the information fairly quickly. We're going to pop into some points, pop out, and there'll be lots of time for questions at the end that we can focus on some of your specific questions that you have. So what's it called? Is it called a green roof? Is it called a vegetative roof? Eco roof? There's all sorts of different terms out there. You know, I tend to say green roof. A lot of people say vegetative. A lot of specs are showing this vegetative as well. But bottom line is, it doesn't matter what you call it, but it is a specialized roofing system. It's a system that's to be working. All the components are to be working in sync and synergy with the roofing system and waterproofing components. So the green roof system types, we'll keep it simple. And these aren't great names when they label these. Extensive is lightweight. Intensive is heavyweight. Simple as that. Think about it that way. But we'll look at it from a few different ways, just so you're familiar with the terms. And you can see on this visual here, the growing medium depth is 2 inches to the left, all the way up to 8 inches to the right. So extensive again, and intensive, over 6 to 8 inches. So the North American market share by green roof types, this is an industry survey from 2019 from Green Roofs for Healthy Cities. The extensive green roofs represent the majority of the market, about 80%. Semi-intensive at 10.6, and intensive at 8.1. Now, semi is kind of a combination, kind of middle ground between the two. But for ease of conversation today, we're just going to focus on extensive, let's call it 0 to 6 inches growing medium, and intensive 6 to 18, 6 to 24 inches of growing medium. Let's forget about confusing everybody with semi-intensive, the middle ground. So the benefits of green roofs. They're multiple, obviously. Aesthetically, they look great. And they add value to a building, which raises the property value. Enhancing the biodiversity. You know, we're reading a lot about the importance of that. You guys know it. It's definitely a benefit of a green roof. Improving air quality, maybe. Hard to measure. But, you know, if there are green roofs on 100% of the installations and buildings across the urban landscape, it definitely would. Increasing roof membrane life. Now that's something that sometimes, you know, green roof, people kind of, a little bit of greenwashing on that part, because yes, it does, it's proven on a conventional roof membrane, but on an inverted system, it's already inverted. It's already protected from the freeze thaw and the temperature variations and such. So you gotta be careful when everybody says, oh, a green roof will make your roof last another 20 years or 30 years longer, okay? That being said, it really does contribute in a way to increasing the roof membrane life. Reduced energy demand, that's in our climate zone, that's, you often hear about that, but keep in mind that, especially in an inverted system, there's not much thermal transfer through an existing inverted system right now. So reducing the energy demand, it's not enough for a payback for a green roof, but for the summer months, it definitely contributes to thermal transfer into the building. Mitigate the heat island effect? Yes, definitely. One of the real key points here is minimizing the land used for stormwater runoff. So we can build our buildings larger, okay, and make our retainment ponds smaller if the water is retained on the green roof. So reducing stormwater runoff and keeping the water where it lands for a longer period of time is really the key benefit that's driving a lot of the initiatives today. And there are many municipal policy initiatives. Many have been in place for a while, but there's momentum for new policy initiatives. Ottawa's got one coming out. Vancouver's got a very exciting new initiative coming out. Mississauga, all the municipalities are all working on different municipal initiatives. But the one that is the most impressive and the most successful in all of Canada, and you'd probably say in the US too, it's one of the top 3 in the US, is the City of Toronto Green Roof Bylaw. I actually, in 2007, I did a deputation to the city promoting the benefits of bringing in the bylaw. This was brought in 2009. And again, this is a whole presentation on its own, but the simple thing is any new commercial, institutional, or residential development requires a green roof. Now for residential condos, you don't require a green roof for a condo residential building under 6 stories, okay? But I won't go through all the math here, but essentially 20,000 square meters or greater, the green roof has to occupy 60% of the available roof space, okay? And that's all designed out in the architectural plans prior to any installation. So the City of Toronto Green Roof Bylaw, cream of the crop for North America, and it's allowed Toronto to be one of the leading cities implementing green roof installations. Other cities in the States include Washington, D.C., and a new policy in New York City as well. Nothing beats Toronto. So now, the design considerations. Sal?
Yeah. There. Thank you very much. All right, folks, so we're switching up a little bit. I'm going to be speaking on behalf of, it's the arrows back and forth, right? Yeah. I'll speak a little bit to the designer's perspective. I don't know how many sort of designers or specifiers are in the room by show of hands. Just going to get a sense. Yeah, we have a few. So you're about to hear the engineers talk, right? So once you hear that, it's usually graphs and figures and CSA standards, and everybody's eyes glaze over. But you're in luck. I'm using slides that Bill helped put together, so there's going to be lots of photos. Minimal of the graphs, though I managed to sneak in a few, and he's been diligent enough to keep them fairly technical. So to jump into it, really when you're looking at a design consideration for green roof, you're looking at a few key elements before you get into the details. The high level stuff is understanding geography, location, and even its relationships to the surrounding buildings, in addition to what is the roof currently? What's the plan? Is it in terms of a structure, metal deck, concrete deck, wood or other? In the case of new construction versus restoration, that can be quite challenging from a design perspective. I'll start with some site consideration issues. So climate zone, building orientation, building heights, wind effects, roof access. Let's dive into all of these. From a climate zone perspective, there's a couple of things to keep in mind, right? There's the plant hardiness aspect to what can grow in each climate, in addition to obviously the thermal performance and what kind of R value you're looking when you're designing them. So obviously in the GTA, we're in zone 6, as you see. So that's kind of a good reference for your initial screening from a vegetative roof perspective. But as you tie it together with the thermal performance of the roof, that's really where you start things off. Building orientation afterwards is, where roofs can survive, where vegetated roofs can survive is an interesting question. The lower you are, the less wind there is, but also you're getting shadow effects and shading effects from buildings around you. When you go up to the top, it's higher wind. Now you have to think a little bit more about irrigation and how much water retention the soil is going to have. But in addition, wind is going to play dynamics with wind uplift. So, sun and shade patterns here is pretty important to think about. Water needs and the system buildup when you are thinking of a building orientation. And you're in a new construction environment, how and where you're selecting the green roofs to be will be pretty important. Building heights, like I described, so that's the wind aspect of the design. So as you go up in the height of the building, wind speeds will increase, so your wind uplift will be increased as well. There's also the question around maintenance and being able to maintain a roof that's 40. I think you had 30, 40, 50-story high vegetated roofs. So the question around how you're able to maintain those roofs during the life cycle when you're in a harsher environment than, let's say, a podium deck roof that's at a lower height. Wind effects, and that's something that I think we spend quite a bit of time on the design aspect of things thinking about. So I'm going to pause here and think about it. There's a few kind of guides or a few things you have to keep in mind from a wind perspective. First, understanding if the assembly is a mechanically fastened or an adhered conventional assembly versus a ballasted inverted assembly is going to be pretty key. Being able to understand the critical zones on the roof and which zones may not be suitable from a wind uplift perspective for vegetated roofs is quite critical. A few standards if you're a designer thinking about sort of tackling a vegetated roof to keep in mind. Certainly CSA 123.24. Which is the standard test for methods for wind resistance of modular vegetated roof assembly. That would be more for a conventional assembly. And the National Research Council of Canada has an online calculator that, the CSA 123.21, it has one for just a normal roof assembly. There is one now for vegetated. So if you're looking for vegetated trays and you want to calculate the wind uplifts for that, you can log online, go to that calculator, and it'll essentially walk you through the considerations. Many are right here on the screen, right? The wind speed based on the location of the building and its orientation, in addition to the parapet heights, the exposure, and what the system that you're putting down. And obviously from being conservative from an engineering design perspective, you're really looking at the system dry weight. But when we get to the structural implications of a vegetated roof, you're thinking about it from a wet, fully saturated weight. Other guides to be familiar with is the anti-spry RP14, which is the wind design standard for vegetated roofing systems. And when we get into the inverted assemblies, the Canadian code is a little, I'd say it's not silent on it, but it's not as detailed as, let's say, FM Global when you're in the US. And there, the DuPont ballast guide for PMR or inverted assemblies is one that we rely on a lot, because ultimately the vegetated medium is acting as a ballast on the inverted insulation, on the XPS insulation or the water sensitive insulation that's on the membrane. So a few things to kind of think about from a wind effect perspective. Roof access and really the ability for a contractor to carry out the work and bring the vegetated assemblies to the work is pretty key for both the construction but also for the maintenance. Other considerations here that I'll zip through, we're going to include the assembly. We'll walk into a little bit of the detail around components within a vegetated roof assembly, some slopes, penetrations. I want to pause at the leak detection and warranty aspects, and maybe we'll hopefully have some discussion afterwards as well as it relates to it. So here's sort of a couple of basic graphics that describe a vegetated roof assembly in two cases. First case here is the conventional assembly. So you see the roof membrane is on top of the insulation, and on top of that, we build out the rest of the vegetated roof assembly. The key thing here to highlight is you see the green components are by the vegetated roof supplier or that contractor in that trade, and then the red components are really related to the roof or the waterproofing aspect of it. And one of the key players or kind of a regular culprits that we see in our industry where things can get confusing is that root barrier. So you certainly need a root barrier when you are putting a vegetated assembly on top of a waterproofing membrane. It's required for the warranty of the waterproofing membrane and for durability. In a conventional assembly, it's kind of simple. You put the root barrier on top and you build over it. In an inverted assembly, so you see here the roof membrane is on the deck and then the insulation is on top of it. The root barrier has to be below the insulation. So now you've taken a component that would live in the vegetated roof spec and you want to insert it within the roof assembly. And that often causes some coordination issues on site. And now you have to manage for multiple trades coordinating to make sure that the root barrier is installed during the installation of the roof assembly itself. A couple other components to pick on here while we're talking about this. I think we spoke about root barriers. To speak a little bit about drainage mats, right, and where the drainage mats go. I think on a conventional assembly, it's simple. It would be on top of the membrane. And in an inverted assembly, you'll see some, debate between having the drainage mat above or below the insulation. So if it's below the insulation, you just want to make sure that you're moving the water above the insulation as much as possible. If that's because of pavers or other fabrics that you're putting on top of the insulation to shed the water. So you're sort of making it into a perfect wall, but in a horizontal orientation. Or as others, even on the panel, we disagreed when we talked about it, having the drainage mat on top, which is more in line with what you see here on the diagram. The last one is the roof membrane. Again, there was a good debate as we were prepping here with the panel around roof membranes and which roof membranes are suitable for an inverted assembly. Manufacturers are the right folks to speak to that if they're feeling comfortable and they're confident with the testing protocols with their membranes. But for us, from a design perspective, for myself, it's always looking for a 2-ply plus type membrane. So a hot rubber with 2 lifts and a reinforcement sheet, a 2-ply modified bitumen membrane, a built-up membrane with multiple layers. Now, that's not to say that others may disagree and if they've installed a single-ply membrane. But if you are, looking to a single-ply membrane to install with a vegetated roof, just keep in mind the thickness and durability that you'll need to maintain. Other considerations are structural loading. I think that sort of, speaks for itself. I would say where it's most complicated, when it's a new build, you know what the wet or saturated assembly weight you design for them. But for a restoration or a feasibility to add a green roof to an existing building, that can become a bit complicated. Here's kind of a few examples of what you could consider from a design perspective. Lightweight and economical, getting at 12 pounds a square foot, all the way to an enhanced kind of higher overburden where you're really driving the weight fairly high. Other roof considerations to think about is the penetrations and really those vegetation-free zones for walkways around the perimeters, and even some fire prevention issues related to having vegetation close to mechanical units or any hot vents that may cause combustibility issues. Lots of design considerations to think about where you have sloped roof and having those shear barriers or geocells. I think Bill, you said the second photo here on the left is St. Lawrence Market. Is that correct? Yeah, so you can see the slope there, and maintaining a medium that can grow can have quite a bit of challenge from a design perspective. Other considerations here related to water access, so making sure that there is sufficient water points. They are on the outdoors, they're not indoors that you have to run them. Temporary sprinklers, and if you're doing any design for a LEED or other sort of sustainability accredited building, understanding the credits that you're trying to achieve as they relate to water use and water efficiency. So for some LEED accreditation, you may only be allowed to irrigate the system for a certain amount of time before it has to maintain itself as a irrigation-free system in order for the building to maintain that credit. Okay, the two things I will talk a little bit more in detail on, and I'm conscious of time, so maybe we'll save some of it for the discussion. But ELD, or electronic leak detection. So that's, we recommend including it. That's a wise investment. It allows you a system to first commission the roof membrane before you put the vegetated roof, which is a Toronto Green Standard requirement. You have to do that commissioning step, often using an ELD, electronic leak detection. Most common one is EFVM, electronic field vector mapping. You might have been more familiar with that naming for it. So commissioning is one, but then the other one is actually leak detection and maintenance for the duration of the life cycle of the roof. So this is an example of kind of being able to pinpoint or find a breach with high accuracy using these leak detection systems. Some of the newest versions of them are actually live, where they connect them to the BAS, and you have it on the BAS, the screen, and one of the grid sections will start flashing when there is a breach there and a leak. A couple of standards to keep in mind with those if you're doing design is ASTM D7877. That's the guide for electronic methods for detecting and locating leaks on the waterproofing membrane, and ASTM D8231. That's, both of those, I would say, they're quite helpful. If you're interested in electronic leak detection, reading them is probably a good start. They give a fairly high overview. The last thing that I'll say about this is, and I know we've had some discussions about it, electronic leak detection, specifically EFVM, electric field vector mapping, in order for it to provide accuracy and reliability in testing membranes, the membrane has to be exposed. So from a commissioning perspective, to meet the Toronto Green Standard or any type of commissioning, you have to do that test before you put the insulation and the rest of the assembly on top of it. Versus after you put everything together, it becomes a diagnostic tool, and you're looking for the water, essentially, you're inserting a low voltage electrical current above and below the membrane. And you're looking for that current to close in a breach, and you'll be able to find it through the electric magnetic fields around it. So, it can, if the assembly is not wet all the way through, you may miss some breaches in a diagnostic environment, but it's important to keep in mind that from a commissioning perspective, you have to have the membrane exposed before you complete your EFVM test. Last sort of slide here to speak to is warranty and the type of warranty implications related to what you're designing or the different systems. So certainly there's the two types of warranties, right? You have your roof type warranty, roofing manufacturer warranty. You also have your vegetated assembly warranties. So there will be two separate warranties. There are some manufacturers now that are offering a combined single source warranty for the full system, from the vegetation all the way down to the membrane. And there's also a vegetated roof overburden warranty. Bill sort of educated me on this a little bit, where the vegetated roof manufacturer would warranty for the life cycle of the membrane that they would come back and remove their vegetated sort of medium to allow for the membrane to be patched or for the duration of that warranty. So that's almost added insurance to it. And then lastly, some warranties related to the roofing components. So they may not be the vegetation itself, but it's the plastic trays and some of the accessories for them not to degrade up to a certain amount of time. And that allows for maybe a re-roofing cycle to happen using the same components. So you just got to put them on the side and put them down. So that's kind of a quick overview of design considerations. I'll kind of pass it back on to Bill, and I'm sure we'll be able to discuss some more during the question and answer. So let me take this one. And the water.
I just want to go back to this slide, just one comment. And Denis, you've said it multiple times. We all say it in the industry. Don't make your roofing decisions based on warranty and what the warranty gives you. Do it on good engineering practices, good waterproofing practices, good green roof practices. This alone is a 2-hour presentation just on the different variables in terms of the warranty obligations, risks, and such. So I'm going to review just the components, and there are multiple components in a green roof system. I'm just going to quickly go over some of the typical components, plants, growing medium, but it's actually called engineered growing medium, not soil, not dirt, water retention layer, filter fabric, drainage medium, the edge restraint, and we're going to review root barrier again, because that's really important for the waterproofing installers in the room here. Root barrier, again, on a protected membrane roof assembly, the root barrier goes on the membrane, okay? And again, that's a green roof component that's being installed by a waterproofing contractor. So there's some logistics involved, some training involved, and you miss it, you have to rip everything up, put it in again. The edge restraint, the metal edge restraint, keep in mind it's not always specified, but when it is in place, it provides a nice clean boundary with the vegetative free zones. It allows water to flow between the green roof and the vegetation free zone. But it's not always specified. Here's some samples where just the riverstone ballast makes a nice clean edging. It's not a perfect line, but it's a nice, good, natural look, natural environmental look. And the other one here on the right is just edging by way of the pavers.
Hey, Bill, sorry, Bill. Just going back one slide, I remember when we were prepping for this, we talked as well about something to think about is watershed, and where you have a tower next to a podium deck, and when the vegetative roof is on the podium deck, think about where the water is going to land from that elevation on the tower. And that usually is a dead zone from a vegetation perspective. But that's really an important design consideration at the very beginning.
So the water retention layer, key to a green roof system, it can be a fleece mat, acting kind of like as a sponge to retain the water. In the tray-based systems, modules, it can be just retained within the plastic tray. And another thing is just a dimple board system too, retaining the water there. So it's an essential component, but it comes in many different forms. Drainage medium here, the photo on the right here is a rolled out drainage medium, easy to install. And again, drainage underneath the modules or underneath the dimple board, it all does the same thing. Drainage medium is very important for that movement of water to the drains. Filter fabric, that's self-explanable. It's just a separator for the growing medium needs to be installed. And let's talk growing medium. It's there obviously to support plant growth. It holds water, but not that much water, okay? Because you don't want it retaining that much water for the performance of the plants. Holds some nutrients as well, but not that many nutrients. What it really does is it helps contribute to stormwater retention and thermal protection, and obviously supports the plant growth. It's a high mineral aggregate, so when you look at it, when you actually run your hands through it, it's you can see the high mineral content, and it's non-organic like a soil. It is an engineered system with its own standards to be followed. And the plants, the functions and benefits, obviously aesthetic, some stormwater retention, selection considerations. You know, they have to be plants that grow on rooftops. Rooftops are a different climate zone than the ground, okay? Even though you may be at the same latitude, the height and the shading, you have to look at that. You want to select hardy, drought-tolerant, self-generating plants that really require low maintenance. Here's a planting method, two different plug planting methods. You can do seeds and cuttings, but really don't see that. That's primarily done in Europe. And plant plugs. This roof here in Hamilton has that picture there, that's 12,000 plugs that were manually planted on that roof there. So it's actually interesting that after 2.5 months, that's the coverage of the green roof. So we're pretty happy with that install, which was in late June, and that picture was taken in early September. Another planting method is to do pre-growing trays, which are often referred to as modules. Very easy to install. And a third planting method is a pre-growing mat system. Probably the easiest type of system to install. And at the end of the day, you've got an instant green roof. This is a photo here in Toronto. I think it's at level 48 on the east side of the city. You can see the picture on the left. The ballast is holding the roof down in the morning when we show up. It's got a decorative white ballast on the outside, but on the inside, it's just a river stone. That river stone will also act as the drainage medium, so it's ballast plus a drainage medium. And at the end of the day, that area is totally green for as long as that roof lasts, next 30 years. So some of the benefits of pre-growing mats and trays. Again, I mentioned it before, you've got your instant green roof. And with that instant green roof, it really reduces the chance for wind erosion and rain erosion, any storm events that come up in the early part of the season after it's installed. It's got real quick installation. The mature plants on the roof have a higher success rate, and it's very easy for repair. Access to the membrane to remove any of the components. It's simple. So I'm just going to go over a few design challenges and have some fun with this. Again, this is another 1 hour presentation on its own. Mechanical unit access pass. You can see in the arrow here is the access pass that the mechanical contractors take. Even though there is very ample ways to get there, a mechanical guy, HVAC guy, will always take the shortest route. So you're going to see, oh, there's no mechanical contractors in the room here. But, you know, same as roofing, they keep the maintenance crews very busy. Canopies, this is early in the design phase, this should be caught. Here's a canopy on the left here. You can see it just at the top of the picture, but you can clearly see the fact that there's no rain getting there to the one half of the roof, and there's rain getting to the other half of the roof. So nothing will grow in that area, not only because it's shaded, but because of the lack of moisture. And this other picture here in Mississauga, same thing. It's really clear, you can see the canopy. So that has to be addressed. And those are difficult remediations to get those green roofs running back up. Reflective surfaces are a problem. The light reflected from curtain walls, light reflected from the windows really play a role in affecting the performance of the green roof. This is one here, runoff from a higher roof above, a sloped roof above. You can see the line there where during rainfall events, everything is dropping down, way too much moisture in that particular section of the green roof. So nothing's going to really grow. It'll grow, but it won't grow properly. So those things need to be caught early in the design process. And exhaust vents. Nothing, the green roof, you know, it's really difficult for anything to grow when you've got 24 hours of air exhausting pushing down and out onto the green roof system. So early in the design phase, you're going to need to do a much larger vegetation-free zone around exhaust vents just to accommodate. And at the base of the exhaust vents, don't do green roof at all. Just keep it separated. Our repair crews are out there. You know, every week we're getting a call. Can you take this out? Just put a Riverstone ballast down. And it's the right thing to do, but it should have been done earlier in the process in the design phase. So some of the other installation challenges, and again, this is a 10-hour presentation. Material logistics, getting materials to the roof is complicated. There's a lot of seasonal variations, seasonal challenges. So it's not just like bringing up your insulation and bringing up your Riverstone ballast. There are a lot of logistics involved, a lot of communication involved. You know, we get calls, the tower crane is coming down in a week, or the elevator's coming down. You got to get your materials up there. There are challenges, especially in the winter. A waterproofing contractor may finish their job in November and say, okay, we're ready for the green roof. Well, we can't bring it up until April, right? So that's the waterproofing contractors, your job sitting there, and you're not being paid for the full job until the following April, just because we can't get the materials up in the winter and plant them. And oftentimes we're running inside the service elevator, so everything's been taken down, and we're bringing all the material up the service elevator. So that's a real barrier to, as a barrier to profitability, that's for sure. But oftentimes, especially in finished condos, when you're going to the top, you're going to the penthouse floors, and you're bringing all your green roof materials up through the penthouse floors, and then finding a way to get it up through wall-mounted ladders and up stairwells and such. It's a challenge. Other trades, coordination with other trades, and Denis is going to expand on this as well and talk about this. But again, we can talk about this for a while. This picture here is a green roof install in Etobicoke. Nice green environment. Couple months later, you can see the wall cladding company. We had left lots of room for them to work, but they dropped their materials down on the green roof. So who's responsible for remediating the damage caused by that? So that requires a lot of communication and, with other trades, and it's a challenge. It's a real challenge. Temporary ballasting during the day while you're working, at night when you leave the job site, that's really important. Logistically, you have to do that right. And irrigation, it's really important to have strong, qualified green roof irrigation contractors working with you. And there are things in the spec that are often overlooked in terms of the irrigation layout, the irrigation components, and how it's integrated with the building automation system. So irrigation coordination is often an installation challenge. And let's talk about maintenance, the fun part. Maintenance is essential for every green roof. You shouldn't, things happen when green roofs are not maintained. So typically the frequency is, in the first year, it's on an extensive green roof, 6 to 8 times. And in subsequent years, it's 4 to 6 times per year where maintenance crews should go up there and do green roof maintenance. On an intensive system, you need more green roof maintenance visits to do the weeding and look for invasive trees and shrubs and such. So maintenance is essential. I'll just point out this sumac on the picture to the right. The client here at the university absolutely loved the sumac. Real nice looking design element on the green roof. But we went up and said, okay, it's time for them to go. They gotta go. You like them, but the maintenance team is looking at this to try and protect the roofing manufacturer. Eventually, when you have trees and shrubs on a roof, the poplars, there's going to be, even though you have a root barrier, there's going to be some intrusion to the membrane. So, although they look great, they have to go.
Sorry, Bill. On the maintenance topic that you had with the previous slide, there is a case study, I think it's in the US, where there was a vegetative roof collapse, and the collapse was eventually traced back to the fact that it was an intensive system, so it was a fairly thick overburden, and all the designs were correct from an engineering perspective, but there was lapses in maintenance, and the shrubs grew long enough that the snow accumulation exceeded what the designers had initially anticipated. So just the maintenance aspect of it cannot be understated.
This is just a quick slide about green roof protection during renovations. The contractors were asked to step aside and go. Did they do that? No, you can see the pathway. One of the solutions, though, is to put down the maintenance team when there are exterior renovations to protect a green roof, put a plastic grid down. This was a great installation. It was actually a well-installed roof, but had no access to water for 9 months. So this is what happens when there's coordination between all the different design elements. I'll just close off really quickly with just a quick discussion on some of the industry trends. This is the fun part. This is another 5-hour presentation here. But gaining momentum, our 24/7 continuous monitoring of the green roof systems from the site to the data center to the customer to the contractors, the irrigation contractors and such. Blue roofs are really gaining momentum. There's a lot of integration with solar and integration with the terraces. Rooftop farms, you're hearing a lot about. Honey harvesting. We're doing some logos on roofs because they want from the Google satellite view to see the company logo on the roof. Detention, meaning you're keeping the water on the roof for a longer period of time just to help with stormwater management. Native plants are a big discussion. And gaining momentum, really. There's more green everywhere. You know, soy black line, but everything's being green, and it's pretty positive. So thank you. Hello, everyone. My presentation is going to be really short there too, but it's going to be a presentation on bad practice. So I'm going to go fast, but hopefully you're going to learn a lot from this and not to duplicate those same mistakes. So basically, vegetated roofs are not new. You got that from an old book. There's like the roofing Bible in Canada there, a roof from Maxwell Baker, written in 1980. Is it 1980? Yeah. And you can notice that the membrane is on the deck. So that concept of membrane directly on the deck has been around for a long time. And in 1966, I was not involved in that project. I was only 6 years old. But this was the first protected membrane roof assembly in Canada. And of course, they used vegetated assembly. If you go downtown Montreal, it's a nice place to go. And it's still there today. Now, the extensive green roof, these are technology that we imported from Germany in the late 90s, like in 1998. So it's nothing really new. We just take all the knowledge from the German that they built up over all these years and we made them into a Canadian way. And that's been doing the work for the past 30 years. Here again, the product we use mostly is rubberized asphalt. It's a monolithic seamless membrane, and when we talk about roofing membrane, well, we talk about mostly is a waterproofing membrane. There's a difference between a waterproofing membrane and a roofing membrane. The waterproofing membrane is designed to sustain hydrostatic pressure for its design life. Okay, and when we talk about rubberized asphalt, our design life so far, it's been, we can say safely that we have projects that have been around for 50 years. Okay, so basically when we design a vegetated roof, we go with a waterproofing membrane that can withstand hydrostatic pressure. So rapidly, this shows you the three types of roofing. You got the semi-intensive, the intensive, and the extensive green roof. First thing is training, okay, in your specification. For those who are writing specification, in the first part of the spec, we need qualification. So make sure that the contractor, both contractor that will be installing the vegetated roof, understand the vegetated roof. The roofing contractor, waterproofing contractor, and the landscaping contractor. So this is key for success. And now I'm going to show you some failure. So this is a college in Montreal, in my neighborhood, and it was built 20 years ago, and under that dead patch there's an underground gymnasium. And it's been like that for 20 years. And the reason why is for what we call value engineering. Okay, they reduced the component. I mean, the architect, they made the design, everything was good, but then we need to remove some component for some saving. And they did that, but they ended up like this. So you can negotiate with the contractor, but you cannot negotiate with nature. If nature doesn't get what it needs for the plant to thrive, it's going to die, and you're going to have this type of situation for the rest of the project. Now, this picture was taken on a large green roof we're doing right now with our public transportation in Montreal. And that picture was taken 2 weeks ago when the roofing contractor went to the roof and he saw another tray stripping out his membrane. And that's because some element did not fit. So he needed to remove the membrane. So he took the Liberty initiative to remove the membrane. So you need to have your eyes open. This is a vegetated roof, an extensive application. It's a public project. Everything's going fine. That roofer is doing his first vegetated roof, but there's a big problem here. The wall is not finished. You see, when we install the sedum carpet or the vegetation, it needs to be the last operation on the site. because they're gonna come up with scaffolding, do the bricklayers, and ruin the vegetated roof. And this is what happened. And then we had to restore. We were able to save that roof, but to a lot of expense. So I want you to don't do this again. Same thing here, downtown Montreal. We did that roof. It was nice and beautiful. We maintained that roof for a full summer. Very intense when we start at the beginning of the vegetated roof. Then in the fall, some other trades came in and they use it as a lawn to put all their equipment and labor and so on. And the next spring they called me and said, Denis, your roof is dead. I said, how come? So I went up to the roof and it was totally dead. So we need to restore that roof. So keep in mind that when you make those vegetated part is the last thing to go down, because these are costly mistakes. Here again, we were able to salvage the roof, but it was expensive. And this application, it's another trade that came from underneath and not a mechanical, but maybe electrical, I don't know, but they did puncture the deck. They screwed the screw on the higher end of the flute, and they punctured the membrane straight across. This one is another one where the contractor had to put down a drainage board, and these drainage boards, they come in rolls, and they have a memory, they come back, so he took the initiative to nail it down. So he used nail, and of course the nails were longer than the insulation, and that was easy for the consultant to find the leak, but here again, need to be avoided. In this particular case, because we're working with two trades here, and the filter sheet is like in between the two trades. Who's doing the filter sheet? In that case, no one. No one was doing the filter sheet. So I happened to walk by that day and I could see the landscaping being done and putting crushed stone directly in the membrane. So if no one's there to pay attention, well, of course, that's going to leak within a year or two. We spoke about that mechanical thing. I'm not going to stress on this. Same thing where you're going to have heavy traffic. You do need to put some pathways. Same thing here on that design. The landscape architect made that nice path there, but it's not only the mechanical contractor that likes the shortcut. Human beings in general, they like the shortcut. And in that case, the bus stop is on the corner there. So whenever there's a big rain, they don't use the path. They use that. They made up another trail. So this is to consider when you design a green roof. And this is a dead roof, and it's always going to be dead because it's been built between 4 towers. So the sun never shines there. You need at least 4 hours of sunlight a day for the vegetation to grow. So I don't know what went through their mind when they designed that, but it's not our roof. Of course, some of these are our roof, some of them are not our roof, but in that case, not our roof. And I don't believe there was any consulting with professional on that job. On that project, there was some architect in there involved, but it's the solar radiation from the panel. And it really makes it really hot, so it's very difficult to have vegetation to grow there. So you need to consider that. This project, it was in Ottawa, and they called me and said, Denis, the roofing material is melting. I said, melting? I said, yeah, come and see this. So this is the filter sheet, and it's solar radiation from a building across the street. Makes like a magnified glass, and it really burns the material. You can see it does like a scanning over the whole day there, and you put your hand there, it would burn you. So this is also to consider. This is wind desiccation. If you're near an airport or a big open space and there's a lot of wind, and then this will dry the plants. And if there's not enough moisture in the soil, the plants will have a hard time to grow. So this is building exposure. In this case, that was way back in the 90s, and it's not in Canada, it's in the US. And for some value engineer, they use the excavation soil to put it on the roof. That was at the beginning, but it's a very stupid mistake. In this case, they used very highly organic soil. Okay, like you mentioned, Bill, needs to be mineral, at least 80% mineral, a little bit of organic. In nature, the soil is about 6% organic, so you don't need that much organic, okay? In that case, it was way, way organic, and you could see moss growing, there's no drainage, and the plants, they die. And also, when it's too organic, this building is where you're not allowed to smoke, and this guy, he wanted to have a cigarette, then he went to the roof, and he threw out his butt, and the roof got on fire. So here again, there's some standard that came up there, ANSI SPRI, standard for fire, so you need to use a mineral soil. Wind uplift, that's another issue. Of course, this is a very high wind situation. In New Jersey, Sandy, it's a hurricane actually. But in some case, in the same area, there was some vegetated roof that did support the high wind. There's ANSI SPRI 14 there for wind design, so you need to consult these standards when you design your roof. There's another one there in Quebec City where you can see there on the perimeter, this is where you got most of the wind turbulence. And you're not supposed to have vegetation against the parapet. It's supposed to be a vegetal free zone. But here again, there's a failure. So this is ANSI SPRI for the root barrier. We've talked about the root barrier. This is a little bit how it's done. They do those planters, they put the root barrier, and they put down bamboo with very aggressive root system. They let it grow for 2 years. And then if they don't penetrate, then the root barrier meets the standard. And maintenance, here again, you need to work with crews that understand green roof. I found that picture a little bit scary when you got a rototilter on the roof there and you've got sensitive product underneath. So you need to always work with qualified contractor. And in closing, these are little components like the checker block, they're made of concrete where you can extend your vegetation into the high wind area of your roof to ballast the roof. And I've got another slide where for sloped application, and also the next thing, because of climate change adaptation, stormwater management in Toronto, Montreal, Halifax, every big city, our system cannot withstand all those big rain events. Now we are asked to have more water kept on the roof, so we've got those controlled flow drain. We've got these permavoid there to capture the rain, so it adds additional water retention to the system. So basically, that was my presentation. So we're going to move on to the question period.
Yeah, excellent presentation, all three. Boy, is that really loud or what? So yeah, if any immediate questions that come to mind, feel free, Bill.
Yeah.
Winter. So how do these things, especially when it's freeze thaw, where the ice doesn't totally melt and then refreezes and then snow falls again?
Well, for the plant selection, we select plants that are climate adapted to our climate change. I mean, not climate change, but climate zone. So the plants that we select can withstand those freeze and thaw cycle and so on. It's not a problem.
You as the manufacturer, are you guys selecting the plant, or is the landscape architect?
It's the landscape architect, but we can help them, but that's their role. The landscape architect choose to make the plant selection. But he can always consult with the manufacturer. Some of the manufacturers, they have in-house landscape architect or agronomist that could help support the landscape architect.
Okay. The other question is the weeds. Like weeds, the pollen, everything is in the air. I mean, how do you prevent noxious weeds from taking
Well,
over?
if your vegetated roof is nice and healthy, okay, it's going to be very dense, and it's going to be difficult for weeds to establish themselves. If your roof is in bad condition, okay, then you're going to have infestation. You're going to have weeds coming in for sure.
But you're keeping this medium, this growing medium, like as an ideal growing substrate for weeds, right? Because you have your high water system. irrigation system up there as well. So isn't that like weeds are not grass because we can't kill them with everything nowadays?
Well, I mean, when you look at that picture, there's a mix of sedums, okay, and it's very nice and tight and dense. Still, it's difficult for the weeds to establish themselves. They compete against these plants. And the environment that we create for these plants are perfect for these plants. Of course, if there is maintenance, there is no green roof without maintenance. That does not exist. In the maintenance program, you need to go there twice a year. And of course, there's going to be weed removal. There's always going to be a little bit of weed. But yeah, maybe Bill, you want to add up on this?
Physical weed removal. And weeds. And weeds do occur on the roof, and because of nature and the birds and such. So it is physical removal, and our maintenance teams are up on the roofs 4 to 8 times a year, depending on the manufacturer's requirements. But most important is the removal of the saplings, the poplars especially, and the sumacs and maple take root. And when the maintenance team is removing those, it's not just for the performance of the green roof, it's for the performance of the roof, because that tree sapling will eventually make its way down to the roof membrane.
Past the roof area.
Yeah.
Jordan, you have your hand up.
And so we do a lot of parking garage restoration, we use a lot of hot rubber as well, we do similar application, a lot of protection goes down and provide something here. But you're talking about trees establishment, because we get that question a lot. In my experience, unless the membrane is gone or something, I don't really see roots get underneath once there's many issues with the membrane. So you're saying saplings start, they'll manage the water.
If the saplings start, you want to remove them as saplings.
Right.
But as they mature, it'll eventually find its way to the waterproofing membrane.
How long before that actually can?
The trees grow at different rates. We never actually see it because we're always removing it, but let's say a sapling in 10 years, I would say possibly, especially a maple. Well, it will take personally, I've seen those conditions on parking deck there, at a podium deck where there was like a foot of soil, but there was like this maple with extended root system. And it took 20 years before it takes a long time before the root penetration will occur. But now, today, with the Canadian Building Code 2015, whenever you've got vegetation over a structure, you need to put down the root barrier. Yeah. And Sal, if you can elaborate just on vegetation that grows, trees, for example, and how it may affect the wind uplift ratings?
Yeah, I mean, ultimately with one wind uplift ratings, you're sort of thinking about it in 2 components. You're thinking of the roof itself and without vegetation and how it would behave, and then you're thinking about what's on top of it from a vegetated sort of medium. And really, the heavier that those components, the more that you are relying on them as a ballasting type tool. Now, having said that once they become sort of larger trees, once they become larger vegetation, wind uplift can also, or wind dynamics can play a role in how they can stay alive or die from a drying perspective. You're also worried about them from just like a high wind environment that wouldn't allow them to thrive. And then lastly, and I mentioned it a little bit, is snow accumulation. So, more larger shrubs and vegetation will attract higher snow accumulation that may not be in line with the original design assumptions at the time of installation. Bill, is that sort of touch on your question?
All right, I'm going to ask one final question, and then if you have any more after, please feel free to come up. Denis, you've got to catch a plane, so we're going to move along. I'm not sure how much of existing roofs can be converted to green roof, and if so, in seismic zones, how does that influence with design? I mean, we are in a very slight seismic zone here, or in other areas of the country, BC, of course. If you're entertaining that or they're doing that, that would be something pretty serious to consider if you're adding what I assume is a lot more weight to the top of a building.
Yeah, that's an interesting question. I wouldn't say that I have direct experience with seismic vegetated roof design, but I will tell you off the top of my head, I think, when converting an existing building to a vegetated roof, we go through a feasibility study first. And that feasibility study tries to kind of identify, we started the loading capacity of the slab. That's really what will determine and be the main constraint to what you can build on top of it. I appreciate that probably at that stage, a lot of the seismic requirements will be taken into effect. Seismic as well has to do with mechanical units and anything that's been elevated because it has to have a lateral constraint. So I wonder if there's maybe some of the zones around it will change a little bit, but all of that will be caught in that feasibility. Once you have those, structural loading availability and capacities, that's what you start from. And I'll be honest, what I find from our experience, when an existing building retrofit to install a vegetated roof, you're wading into a tough conversation around the existing capacity of the structure. You have the existing drawings. At times you don't, as we all know. You have potentially the permits, and you're assuming that it was built to the codes of the day. So what ends up happening, the structural engineers take a very conservative approach. And that's a constant discussion between the design team on, it must carry more, but there isn't enough evidence, and no one wants to take that liability. As you can imagine, it's a very large liability to say a structure can carry more than there's enough evidence for it. But that would all come out of that initial structural feasibility study.
Okay, thanks. On behalf of the Sealant and Waterproofing Association members and board, gentlemen, thank you very much for your informative discussion today. It was very interesting. We have a token of our appreciation, Denis, Bill, and Sal. Once more, thank you. Marla, you want to come on up? So, gentlemen, thank you again, and have a great day.